Hi, I'm Teacher Malyn. This time, I will discuss with you Lesson 3. It's about factoring quadratic trinomials. So we have two sets of factoring quadratic trinomials, but we will start first with factoring perfect square trinomials, wherein the first and the third terms are perfect squares. So you know already how to identify terms which are perfect squares. So let us, in factoring perfect square trinomials, we will be guided with the formulas, two formulas. The first formula is a squared plus 2ab plus b squared equals the quantity a plus b multiplied by the a plus b. You will notice that the two factors are exactly the same. And we can express this also in squared form or in exponential form. A plus b squared. So, this formula will be used if the operations of the second term and the third term are both addition. What about if at the middle, the sign of the middle term is subtraction? So we have to make use of this formula so that when we get the factors, the operations at the middle between A and B are both subtraction. So the second formula that we need to use should be a squared minus 2ab plus b squared equals the quantity a minus b multiplied by a minus b. Thus, I can write this in exponential form as a minus b squared, since both factors are exactly the same. Let us have example number 1. Let us first identify if the first term and the second term are perfect squares. Do you think 25m squared is a perfect square? Yes. What about 36? Yes. So we can now follow the formula, the first formula. You can write equal sign here. Letter A, the 25 here represents the A, and 36 here represents the second term B. So, what do you think is the square root of 25m squared, or the square of 25m squared? Anybody? Can you still remember how to get the square or the square root of the squared term? So, what number should be multiplied by itself to get 25? Is it? It is 5. What about m squared? What's the square of m squared? It is m. So, you have to write now two parentheses. So, you write 5m here, following the formula, also 5 here, 5m here in the other parentheses. Since following the formula, both here are plus signs. Then get the square of 36, which is 6 and 6. Let us check if we will arrive to the same answer, same trinomial, I mean. Checking. By checking, you do the FOIL method. The first terms, outer terms, inner terms, and the last terms. Okay, let's start. We have, do it here below, 5m plus 6, 5m plus 6. Oh, sorry. Plus 6. You have to adjust. Plus 6. Okay, FOIL. So we have 25m squared outside terms. We have plus 30m, inner terms, 30m, last terms, 36. We only simplify terms which are like or similar. Then copy 25m squared plus 60m plus 36. Did we arrive to the same given trinomial? Yes. Do you understand? Were you able to follow? Okay, very good. Are you ready for an example number 2? What do you notice with a trinomial? What do you notice with the first term and the third term? Are they both perfect squares? What do you notice with the sign of the second term? Okay, so this means that we have to follow the second formula. Because in the second formula, the sign of the second term is minus or negative or minus or negative. So since this trinomial follows the formula, the second formula, we can say that the signs of the first and the second term should be subtraction or minus sign. Then, give me the perfect square, the square of 9x squared. What about 9 first? What is the square of 9? Of course, it is 3. What about m squared? It is m. Following the formula, a here and a here. So we will just copy here, 3m. And then 64, what is the square of 64? It is 8. So 8 here also. The square of n squared. So it should be n, and we have n. And I can also further write the factors in exponential form such that 3m minus 8m squared. Okay, we can have the checking just like what we had in example number 1 by using FOIL method. So you have 3m minus 8n times 3m minus 8n. Okay, doing or following the FOIL method. Okay, the first terms, we have 9m squared. The outer terms, we have multiply 3m by 8n, we have 24 mn. The inner terms, we have 24 mn. The last terms, 8n times 8n, positive 64n squared. Then simplify the like terms. Copy 9m squared minus 48mn plus 64n squared. What do you notice? With the given trinomial and after checking, we arrive with the same perfect square trinomial.